time when Joel gets that done. I am Mike Whirling. We're a technical specialist agronomist here at the conservation at the SWCD and a conservation advocate at my farm with many years of restorative agriculture. Please keep your audio on mute unless speaking to us, and use the chat function to ask questions. We will be monitoring chat. Excess nutrients such as phosphorus and nutrients leaving our farm is contributing to the water quality issues in Lake Erie and the Mississippi River. Today we have with us John Mischler from Merry Lea Environmental Center at Goshen College and Ben Wicker from the Indiana Agriculture Nutrient Alliance. They're going to give us the picture of nutrients in agriculture. I guess let's start right off with Ben Mischler. Can you tell us about yourself and tell us what we need to know?
Howdy, folks. So I'm John Mischler. I'm over here at Merry Lea, which is part of Goshen College, but we're not in Goshen. We're closer to Columbia City. So basically, we're halfway between Goshen and Fort Wayne. And then I also know, and then Ben, you'll be presenting later after I present. Is that correct, Ben?
Yeah, that's our intention. Thank you.
Can't find my mute button. Yes. Yep.
And so, Ben, I don't know. So I'm going to sort of give sort of one side of nutrient management that should be complementary to what you're giving, and you're probably going to give some good practical instruction. So I don't know if you wouldn't mind just taking 30 seconds or a minute and just letting folks know what they're looking forward to in your talk, so they can kind of sit tight through mine.
Sure. Yeah. So I'm going to go through, I guess, a framework called the 4 Rs of nutrient management, and kind of explain what those are, and then give some different ways that as you're developing your plan for your farm or on your at your home, how you can apply those strategies. So I think I think it'll complement really nicely into John's to hear a specific case of this is how you do it on your farm, and mine will be a little more broad as far as these are some overall considerations as you're developing that plan.
And so, and Ben, correct me if I'm wrong, if folks are kind of looking at wanting to know how to calculate rates, things like that, that's sort of some of the stuff you might cover.
I don't have any specific rate calculations. That's something we can go into if we have an interest in that, for sure. So.
Okay, cool. Thank you very much. So just sort of setting the stage for kind of what we're in for this morning. So I am going to go ahead and share my screen here. Okay, so if someone could give me a thumbs up that they're actually seeing a presentation that says nutrient cycling.
Yep,
okay.
We can see it.
We're good. We're seeing the slideshow presentation.
Okay, perfect. We're good to go. So I'm the director of the farm here at Merry Lea and the director of our agroecology program. And so I'll be sort of approaching nutrient management from the agroecological lens. And so we'll flesh out what that means here in the first few slides. So as I was saying, Ben's going to be talking about the 4 Rs, which is a great conversation to have, and probably have some of the practical information that should complement, like what I'm presenting should complement what Ben's going to be talking about. So Merry Lea, we're an educational and demonstration farm, focusing on sustainable practices in agroecology. And so that is getting your biology, really emphasizing getting your biology to work for you. So as I mentioned before, we're up here in the northeast corner of Indiana, right between Goshen and Fort Wayne, so close to Columbia City for you folks who know where that is. So we focus on teaching everyone from kindergarten all the way up through adult learners. So we've got we've got a K through 12 program, running students through gardens, helping them understand where food comes from, all the way through to a college major that we bring college students out there in the summer. We've got high school students working with us, and we have adult programs where people can learn how to start seedlings, milk goats, make cheese, all sorts of fun stuff. So this is all of the amalgamation that is Merry Lea, all these different red blocks. It's 1,200 acres. And here's Bear Lake and High Lake for those folks who know where that is, in the town of Wolf Lake up here. And then this 100-acre section here is what we call the farm. And then we also have an experimental grazing project going on over here, looking at using prairie strips and being able to graze prairie strips as part of your rangeland management plan. So just zooming in on what we call the farm, I'm going to give you folks a really quick tour just so you know where I'm coming from here. So we've got sort of mixed silvopasture up here, so just sort of trees and grass. We've got our residential area here. Then we've got our barn and our greenhouse, small hoop house. We got ourselves an orchard, a wetland here, the large wetland here, which that catches everything that's coming off of our land, but also our neighbors here to the north. So it's catching all that. It's nice and warm and shallow, so it ends up being really productive. So a lot of those nutrients that might be running off any of our, in any of the areas around us, they're going to be sequestered here and caught up in the biological system, so that they don't end up flowing downstream here into the ditch. We've got a historic farmstead. We've got a nut orchard on top, and then we've got this agroforestry planting over here. And then here's our vegetables here and our learning garden here. So we have a pretty complicated landscape that we manage. It's a multifunctional landscape. So we've got everything from agroforestry to gardens to pasture to wetlands to forests and prairies. So, and we kind of make this whole landscape kind of work for us towards being able to run the farm. So, and again, I'm just going to give you folks a few pictures from on the ground to kind of understand, where we're coming from here. So this is, I got to take some new pictures because this is actually from a couple years ago. Anyway, our forestry project, we run cattle and chickens through that. And also we'll do pastured poultry. We try to keep them well protected because the raccoons would really like to eat those Cornish cross chickens. So we were able to spread their manure out across the pasture after the cattle have come through, so that basically, as long as we keep moving those mobile tractors, the chickens are spreading the manure for us. Then we've got our greenhouse spaces and goats and other animals that students are working with. Okay. So now we're getting to the point where we're going to define this nebulous term that's agroecology. So it's been defined a lot of different ways. And so we're going to sort of refer to these different levels that are sort of deepening our participation in agroecology. So level 1, we're going to increase input use efficiency. So for example, if you're using nitrogen fertilizer on your farm and you want to use less but still get the full benefit of fertilization, then you're going to think of ways to basically increase the bang for your buck, whether that's timing, whether that's the type of nitrogen you're applying, so that you've got less nitrogen leaving the system and more nitrogen staying in the plants on your farm there. So increasing input use efficiency, and then trying to reduce anything that you use that might be really costly, right? Really costly inputs can be pretty hard to maintain, or any of the more damaging herbicides or pesticides. And so I'll say, I personally believe that an herbicide or pesticides are part of the tools that are in a toolbox. And again, depending on what certification or markets you might be serving, but it's something that we have to use carefully in order to be able to manage our system while given if we've got constraints on labor or cost or things like that. So, and then level 2, so we're trying to limit more of these sort of potentially damaging inputs. So we might be increasing, we might be relying more on integrated pest management. Some of the beneficial insects that we have around, we might be using more compost that we can get from local sources rather than fertilizer. Level 3, now we're starting to get into the ecologically based aspects of agroecology. So this idea that we're setting up this functioning ecosystem, right? And we'll spend most of the rest of the talk today on this idea of level 3, this idea that if you are able to successfully set up your farm as a functioning ecosystem, that there are interactions that happen across your farm in your soils that actually work for you, right? To not only make your system more resilient, but also can provide you stabilization of yields, whether you're vegetable farming or grain farming. So one example of this is farming in a way that you're accumulating soil organic matter. And soil organic matter is going to also act like a sponge and be able to help regulate water, right? Keep water in those soils for a longer amount of time when things start to dry out in the summer. So, and then level 4 is of agroecology is this idea that we are wanting to connect those who are growing food and those who are eating food. Now, whether that might be through educational opportunities or it might be through things direct marketing, like farmers markets or CSAs, basically being able to close that or get rid of that barrier that so often exists that people have no idea how their food is produced. So this is agroecology in a nutshell. This is the lens that we're coming from here at Merry Lea. This is what we practice. And so this is going to be useful in sort of understanding where I'm coming from. And so that's why we can't talk about nutrient management without talking about all of the different organisms that live in the soil, right? So all sorts of different fungi, bacteria, endophytic fungi, these endophytes that actually are able to live within organisms, right? That span the whole range from really not interacting at all to being symbiotic, so working together with plants, all the way to being parasitic. So there's a whole bunch of different endophytes. Mycorrhizal fungi, which are able to basically augment the roots' ability to access nutrients, and nitrogen fixing bacteria. So those plus the whole host of organisms that live in the soil are crucial, right? They're crucial for nutrient cycling. And so I'm going to take just 1 minute here. I missed a couple of these while I was gone. Have we talked about the soil food web at all in any talk yet, or are we proposing to talk about one in the near future?
No, go right ahead, John.
Okay, I wanted to make sure I wasn't stealing anyone's thunder here.
You're good. Go for it.
Yeah, it's crucial to talk about living soil and a soil food web when talking about nutrient transformations and availability of plants and all that good stuff. So I won't go into deep detail about the soil food web, but we will be talking about it. So I'm just going to take a minute here. I don't know who all is on the call. I'm seeing a few, I'm seeing a bunch of familiar folks. Is there anyone on the call here who is currently running their own small farm or urban farm, or is interested in doing so in the near future? If you are here, just go ahead and if you want to just say hello.
There's also a function where you can raise your hand in the so if you click on reactions, you can give a thumbs up. Okay, it looks like Rich Barker is raising his hand. Marissa Renz is raising her hand. Robert Johnson, Stephen Pulowski, Paul Doctor.
I see Kelly Atkins on there from the Solomon Farms here.
Ramy Porter, Kelly Atkins is Margot Nussbaum. Sorry if I pronounced that wrong. It looks like they're all the ones raising their hands.
So what I want to do here, and I know it's, I know it can be challenging over Zoom, but I want to get a little bit of an idea of the expertise that we have sitting out here right now in this meeting. So I was wanting to pause for a second and talk about the connections between soil life and nutrient cycling. And so for those folks who are already managing their soils for soil life, I'd be curious to hear what their perspectives are on how they nurture soil life in their operation and how they see it as important for nutrient cycling. So,
well, let me start. I farm in Adams County, Decatur address, but along the St. Mary's River, and have been starting no-till and cover crops back in the late 80s, early 90s. And the increase in soil organic matter that I see is feeding everything else. It's the mineralization that's supplying the nitrogen to my corn crop. So I put less on, I apply less. It's the beneficial insects, the beneficial fungi, the beneficial nematodes. Nematodes get a bad rap by having more beneficials than harmfuls. So I think it's the number one thing.
And Mike, sorry to reverse here a second. So you had said that reduced tilling plus cover crops with legumes, you're fixing nitrogen into your soils, you're not disturbing that soil food web, and you've seen a big difference.
Yep. Yeah. And the latest thing of the planting green, I am planting my corn and soybeans in 5 and 6 foot tall cereal rye, and then rolling it down, roller crimping it after. Laying that mat on the surface is such a benefit. Number one, with water not hitting it, keeping the weeds down, weed suppression, and on and on.
Perfect. Thank you very much. What who else has an anecdote about how they're trying to nurture soil life and kind of the results they've seen and what they're aiming for?
Kelly Atkins giving us a response. She's mobile this morning, can't talk, but they're using compost and other means at Solomon Farms.
Cool. Yeah. Yep. So I'm seeing that. Thank you, Kelly. I see Ramey down at Huntington. He's talking about no-till, slow release nitrogen, and getting more diverse crop rotations, being able to use cover crops. And I'm also seeing Rich Barker. He's working on 60 acres, row crop and pasture land, rotational grazing livestock. So being able to integrate animals into the rotation, which is great. So yeah, okay, I got Marissa Renz, no-till and cover crops, compost, crop rotations. Yeah, and I welcome folks. If you want to put it in the chat, that's fine. If you want to take a turn and talk with us, that's also fine. I know half the time I've got kids in the background while I'm on a meeting. So if that's the case, no problem. But I just want to give folks a chance if anyone else wants to either put anything in the chat or say anything live here. Just go ahead.
If you're new to Zoom, you can press your space bar and get on a temporary unmute. So it's a good way to talk. We have Ramey Porter adding biologicals, Biodyne. I see Paul Doctor's on here. I met with him yesterday. He has a great rotational grazing effort going on and soil health, working towards soil health improvement.
Okay, so I got some good feedback from you folks, and part of the reason why I like to do this is I know that we're an entire community of practitioners, and that, as you folks well know, that what works on one farm, when inside one system, that it might look different if you go down the road to the next farm in another system. And let's see, I've got another one here.
Kelly
Yeah,
Atkins.
that's a good question. And so, Kelly, I'll get to that in a second. Sorry, was there someone else who was trying to speak?
No, sorry, I was just repeating what Kelly was chatting.
Okay, and yeah, so we all have different, we all have different things we're focusing on. So, for example, we're really focusing on the nut, fruit, berry, and vegetable crops here. And so we're going to be doing something different than someone who's, working more with row cropping. But a lot of these concepts are universal, right? And it's regardless of scale, whether you're doing 1 acre somewhere in the city, right? Or you're doing 7,000 acres, sort of more in the rural areas. So that's what's really cool about a lot of these agroecological concepts is they're going to scale up, right? They're going to go from the smallest backyard scale all the way up to the largest production scale. And so, for example, so Kelly asked, do we have permanent fencing? So we have cover crops that we use for, we use a diverse sort of a 16-way mix of 16 different species. And we use that on our vegetable producing areas. And we have a perimeter fence because I've found out that it's not good not to have a perimeter fence. No. And we grew up with perimeter fences, and then we run the goats through using electric fence. And then on the agroforestry project, we also have a perimeter fence. Then we run the cattle through using single strand electric on the inside. So yeah, so we definitely focus on being able to use animals in our operations. Okay, so it was really great to hear from you folks. And we have kind of the interesting situation where we've got a lot of folks that are really experienced here on the call, and I'm sure we've got some folks who are just starting out. Plus, we're recording this, so there may be folks who will benefit from all this experience, who are able to listen to this recording later. And so what I'm going to do is I'm going to sort of step through a lot of these approaches that you folks are mentioning. So so that we kind of have a total understanding of how agroecology can interact with nutrient cycling. And so I appreciate everyone's expertise here, and please feel free to jump in on the chat if you have things to add as I sort of go deeper here. All right, so any other parting questions or comments before we sort of resume back with the slides? Okay, so we should be seeing slides again. So someone stop me if you're seeing something else. So let's go back to the soil food web. So a lot of what folks were mentioning, right? These things like biological inoculants, cover crops, no-till, soil organic matter, compost, all of this stuff. It's multifunctional, right? So for example, someone might use cover crops to keep their weed pressure down, right? To be sort of a living mulch for weeds, but that cover crop is also going to be doing some nutrient cycling for you. And so we're going to be zooming in on sort of the nutrient cycling part of those pieces that we talked about. So already, like I said, already on this call, we've got a lot of great experience from folks who are using a lot of this stuff in their own operations, and they're seeing a lot of results. So, and then, as I mentioned, all of this hinges on having a vibrant soil food web. And so, as folks were mentioning, everything from nematodes to fungi, mites, plant roots, the rhizosphere, pieces of organic matter, plant litter, springtails, arthropods, crustaceans, all sorts of things, right? All factor into what we call soil biology, and that's not even to name all the countless bacteria that are still new to science that live in our soils. So when we're talking nutrient management, we need to talk about soil life. And so, okay. So, and we're going to come back to this point, but right now I'm going to say, I'm going to say that it's sort of in most people's common knowledge that nutrients have to be in an inorganic form or soluble form to be taken up by plants most easily. And so how do we get nutrients? How do we go from a stick or a piece of compost to a nutrient that's able to be taken up by a plant? So I'm going to run through the nitrogen cycle and the phosphorus cycle. I'm going to do it briefly, but you folks are welcome to look it up more in depth online, right? So we have plants that are sitting there happy photosynthesizing, right? You've got living roots in the soil, and these plants are going to be interacting with soil life through the rhizosphere, through the area around the roots. And so we've got, non-nitrogen fixers, right? And we've got nitrogen fixers. So, whether it's corn or tomatoes, your non-nitrogen fixing plant, and your nitrogen fixing plant, your legume, whether it's going to be beans or peas, there's, tons to choose from. They have their own unique types of interactions that they're going to have with the soil. So for example, plants are known to release root exudates. So that's basically, plants pulling down carbon from the atmosphere and then releasing that carbon through their roots, feeding microbial life, right? And so, and fungal life. And then there's feedback relationships then between the bacteria and the fungi that live in the soil or that might be associated with the roots of the plants they are then able to break down. So for example, fungi can break down complex organic material, things like compost. It can break it down and make those nutrients able to be taken up by the plant. So that's this area, or that's this arrow, decomposers, right? So things like fungi who can break down complex organic materials in the soil to make them more easily available to plants. And then you have the legumes, so your peas and your beans and lentils and all sorts of other plants who have these things called nodules, right? So nodules, these nodules formed by bacteria on the roots of the plant, and these nodules contain nitrogen fixing bacteria. And so it's this great idea, right? This great awesome aspect of these plants that they can take nitrogen straight out of the air, fix it in the soil as a form that plants can use, because plants can't take up this N2 nitrogen, but they sure can use the nitrogen fixed by these nitrogen fixing bacteria. And that's, we had folks talk about using cover crops as a way to cycle nutrients in their systems. So this is one way that cover crops are really useful if you have things. And again, you can use cover crops in your backyard garden, your urban farm, all the way up to your 1,000-acre row crop operation. So legumes like hairy vetch, clovers, there's tons to choose from here, but they're going to actually do the work of pulling nitrogen out of the atmosphere and into the soils. And then there's a whole bunch of transformations of nitrogen that are handled by other types of bacteria that I won't go into here. And so basically, you've also got your nematodes, your mites, your arthropods, your crustaceans, all the other life in your soil is eating that organic material. So for example, your compost, or if you're using feather meal, or you're using worm castings, or you're using whatever you might be using, these living components of the soil are what are processing it and making it available to your plants. And so it's similar. So we talked about nitrogen. there's some similarities here in the phosphorus cycle. Except it's less complex because plants can't fix phosphorus. They cannot, sorry to tell you. But so we often get our phosphorus either from manures or composts or fertilizers that basically can join in. So we've joined into the soluble phosphorus pool, right? Basically where you have a bunch of transformations where you can get them adsorbed onto the surfaces of the clay minerals, right, that are in your soils. So phosphorus has this weird sort of situation where you could apply phosphorus, it could get bound up in your soils so that it's there, but it's not available to your crops. But again, the phosphorus is bound up in things like compost or decomposing cover crops or any of the residue, which is which is what's left over, the plants that are left over after you've harvested. All of that can be processed by this soil food web. So it can be processed and made into available forms of phosphorus that your plants can take up. So your crops cannot take up a stick. Your crops cannot use a leaf, but through these processes in the phosphorus and nitrogen cycles, by having a living soil, right? These organic materials can be processed and made into plant available nutrients. So again, we're talking about nutrient cycling here. We're talking about how to maintain fertility at a whole range of scales. And a big piece of it is making sure your soil is alive and providing all the sort of environmental pieces that your soil needs to the communities that living in your soil need to be able to be a happy, healthy ecosystem. And soils want to be they want to be fertile. Soils want to be able to pass these nutrients back and forth, have them be transformed into more labile forms that plants can take up. So that's kind of the lens that we're approaching this from. So we use a whole bunch of different types of fertilizer here on our farm. So we use fish emulsion, we use bone meal, we use feather meal, we use blood meal. And so whether you're an organic operation or whether you are not organic but certified, there's certified naturally grown, which is another certification, or whether or not you're not concerned about certifications at this point. Any material, right, that comes from a living thing, whether it's manure or feather meal or what have you, is considered an organic amendment. So we practice agroecology, which tends to use a lot of practices that are used in organic. So when we do add fertility, again, so we try to manage our systems so that they build their own fertility. We try to we try to use cover crops, use nitrogen fixing cover crops. We don't till, and we have animals graze our cover crops, move the nutrients around. We're able to set portions of our vegetable operation aside so that they're able to get the full benefit of a cover crop mix we might use. And so that's a lot of our nutrient management. But when we do need to go in with focused nutrient additions, you can see the NPK, the nitrogen, phosphorus potassium ratios, which I'm sure a lot of you folks are familiar with. And if you're watching this and aren't familiar with this, these are sort of the main limiting nutrients in a lot of agricultural systems, are going to be different depending on the material you choose. So for example, feather meal, right, which is basically when you've got those large chicken processing facilities, they end up with a lot of feathers. And so they're able to sell that byproduct as feather meal. And feather meal is basically all nitrogen. And so if you're really trying to address a nitrogen deficiency, then you'll use that feather meal. Whereas bone meal, bones are really high in phosphorus. So if you're really if you're fine everywhere else, but you're dealing with a phosphorus deficiency, you might want to try something like bone meal. So anyway, there's a whole every color of the rainbow type of approach to fertilization if you do need to bring nutrients into your system. And none of these are super fast acting, not like a synthetic fertilizer will be, but they do have different sort of time scales that they operate on. But they are almost all of them are relying on the soil food web to process them. And so it's going to be time from when you apply them to when they're actually making their way into your plants. Now, one of the exceptions is, well, there's a few exceptions, but for the ones that I'm talking about here, is our manures. So especially if you're applying a fresh manure, it's going to have a component of it that's really fast acting. Now, we don't use fresh manure for a few reasons. There is a food safety issue with using manure that has not been composted, and it's very easy to apply it incorrectly such that you actually kill your plants with it. So we don't use fresh manure, slurry, or fresh slurry or anything like that on anything that we do. So so this idea, right, that it's just these different paradigms, right? These are two ways to sort of address nutrient management on the farm. And so a lot of what we've been talking about, organic, in that you're using organic materials, right? Whether it's compost or feather meal or fish emulsion, which smells really great. These organic materials, and by organic we just mean complex, lots of carbon chains all linked together, complex materials. They're designed to feed your soil biology, right? And then your soil biology processes it and makes it available to your plants. Whereas the synthetic fertilizers, so a lot of sort of the fertilizers fixed using the Haber-Bosch process, they're gonna go straight into they're sort of applied straight in their soluble forms. They're going to be taken up by plants immediately. And then that's also some of the concern we have about if we don't apply these in a proper rate, which again, we'll hear about rates and this idea of the 4 R's a little later. You just got to be careful not to over apply them so that they end up washing out of the system, which happens a lot with nitrogen. But okay, so if we think about, we've thought about the soil food web. We've thought about how these organisms process organic materials, right, through the nitrogen and phosphorus cycles and make them available for plants. And we thought about all the different materials that we could use to manage our fertility. So how do we deliver these nutrients? So we talked about compost already, right? You can apply compost right on top of the soil. If you got seed bank. So we actually tarp. So we cover crop, we graze our cover crop, and then we tarp the grazed cover crop in order to terminate any of the cover crop that's left, and then we'll apply compost on top of there. And we actually like to do our bed prep in the fall. So we found that if we apply our compost in the fall, and then it's ready to go in the spring, that fits with our workflow, and it also allows time for the biological activity in that compost to sort of be more distributed throughout the soil. And so you can also, if you're doing something more focused, like feather meal, then you can sort of incorporate it into the soil right where the crops are being grown. Or you can do a top dressing, where if you notice you've got a deficiency later on, you might just put it right on top of the soil. And then some of you folks, excuse me, some of you folks might also be familiar with foliar feeding and compost teas. So this idea that you can actually make mixtures, right, and apply it on top of a liquid mixture, and apply it on top of your plants, and they can actually take in nitrogen, especially that way. And so a lot of different ways to, if you do find that you need to provide nutrients to actually apply these nutrients. So we use a lot of compost teas. We do foliar feeding. We try to stay away from adding fertilizer if we can get away with it. Have the soils have our longer rotation, and our soils take care of it for us. But if we do, we do that from time to time, and we are a compost farm, as a lot of vegetable farms are. So we will apply compost every time we flip a bed. And then some other notes. Remember that you're not just adding nutrients, you're enriching your soil community, your biological community, when you're adding things like inoculants, compost. And not all soils are created equal. We've got a really sandy area that we've got an orchard in, and it's really, really hard, right, to get that soil to hold on to nutrients. Nitrogen tends to just, no matter how you apply it, no matter what form you apply it in, nitrogen tends to leach right out of those systems. So when it rains, it just washes right through. So we've been focusing on building soil organic matter on top, so to at least be able to keep those nutrients in place with soil organic matter. And also we've been applying biochar, which we can talk more about that later if folks are interested. But it's basically it's basically cooking wood. So it's that you're actually cooking wood to form a char, which has basically a bunch of little attachment points for nutrients. And you can go ahead and charge it with nutrients. And if you're in a soil where you tend to lose a lot of your nutrients, like a sandy soil, if you add biochar to it, you can retain those. So again, just sort of mentioning some of the approaches we take. And then coming back to this idea, and I just wanted to touch on this because it is sort of a newer perspective on how plants interact with the soil food web when it comes to nutrient cycling. So a lot of what we thought was that nutrients had to be broken down into their inorganic soluble forms like nitrate and ammonium and phosphate in order to be taken up, but we're finding that's not actually true anymore. And I've just put a bunch of resources up here, which I know they're not very useful for you folks to put into your browser here. But if you do just search the Rhizophagy cycle, there's a great paper written by James Miller, and it's And there's also, some, if you just look at YouTube, you can find some great talks on how important it is in managing nutrients in your operation. And so we're just going to talk, we're going to introduce this idea here just to sort of give you folks this idea that plants do things differently than we thought they did. And so this is just like the last 10 years, right, that this stuff has sort of been coming out. So again, I'm just going to cover this briefly. Roots have root hairs, right? So that's what we're seeing. We're seeing a root here, the meristem of the root here, so the very edge of it, and then root hairs coming off of the root. What we are learning, interestingly enough, what we are learning is that plant roots farm bacteria and microbes. So we're finding that plant roots actually farm their own microbial communities. So, and they fish out the microbes that they need, and the microbes actually enter into the roots and nutrients. So these are so just to sort of get our heads around this isn't like, nitrate or ammonium or phosphate, these sort of soluble inorganic forms of nutrients that we've been talking about. These are whole microbes that are entering into the roots and are being processed by the plant. So things like amino acids, parts of their parts of their membranes, they're actually being stripped by the plant, but the plant's actually not killing them. They're then exiting through the root hairs, and they're recharging with nutrients that are found in the rhizosphere, the root area, and then the process can happen again. And so, and this is not just a crazy theory, right? This is actually happening, right? And so if we make these microbes visible, right, so that they fluoresce, we can actually see the flow of these microbes in and out of these root tips. So it ends up that soil biology is even more important than we thought it was when it comes to nutrient cycling, because microbes themselves, so plants are actually cultivating a set of microbes that are then used to basically gather nutrients from the surrounding rhizosphere, and then they enter in through the root and are stripped of these nutrients. They're put out through the root hairs, so that sort of spreads them out, and then the cycle starts again. So I won't cover it in depth, but this idea that soil life is crucial for nutrient cycling is even more important here. And I even manage so plants aren't just taking up soluble, nitrate, ammonium. They're taking up whole amino acids, which are much bigger chunks than we knew they took up before. So lots is happening as far as our ability to understand soil. So everything hinges on keeping our soil living and healthy. So these are just a few hints, and there's a whole bunch more we could talk about. And I know the folks that are here on the call now have a whole bunch of really valuable experience themselves. So keeping our soil healthy and living and sort of managing our soil ecology. So we have to watch out when applying inorganic nutrients. So when we're applying nitrogen and phosphorus as in inorganic forms, so especially synthetic fertilizer or phosphorus, rock phosphorus that's been mined. For example, if you add too much nitrogen, just even as a simple example, if nitrogen is plentiful, then your legumes, your beans and your peas actually don't nodulate. They don't form those nodules that nitrogen fixing bacteria live in. And they don't do that because it's not energetically necessary. There's already nitrogen flowing around. Why would a plant invest in taking care of these nitrogen fixing bacteria, right, with root exudates, if there's plenty of nitrogen around? So, and then phosphorus can actually shut down this entire rhizophagy cycle. If there's plenty of phosphorus around, the root just sees no point in, and I'm anthropomorphizing plant roots here, so you can just bear with me a little bit. But there's no point in running this energetically costly system if there's just phosphorus sitting around. So if you want your soil to work for you, and if you want your whole soil, your living soil community to function so that you don't have to apply nitrogen and phosphorus, then you have to really be careful how much synthetic fertilizer or soluble nitrogen and phosphorus you're adding to the system. Then some other standards that are just good in general: avoiding compaction. You need nice you need nice open soils in order to have reaction points and places for these ecologies to exist. Tillage: every time you till, you're ripping through all those hyphae of all those fungal hyphae. You're upending your soil food web. If you're tilling to the point where you've got bare soil, you're exposing it to the sun. Soil can get really hot, and you're basically sterilizing the top few centimeters of your soil. And if you're using particularly harsh pesticides and fungicides, and like I said, I do believe that there are tools in the toolbox, and mileage varies. So it really does depend on which pesticides, which fungicides you're using. Some are much more broad spectrum. Some have a much stronger effect on soil biology than others. So if you can also directly inoculate. You can inoculate with mycorrhizae, fungi, compost teas, directly adding, upping the biological aspect of your soils. You can also buy, there's also plenty of products to buy that will do this as well. Diverse cover crop mixtures, keeping living roots in the soil as long as possible. So having these covers that are in the soil, through the winter if possible. And having multiple species is also important. So that's why, so we do tarp our cover crops to terminate them. The more diverse cover crop mixture you have, the more challenging it might be to terminate them, especially if you're in an organic system. But having these diverse plant systems seems to really up the biological activity of the soil. And this idea that not all nutrient sources are equal, you might have heard someone say a pound of nitrogen is not a pound of nitrogen. Some nitrogen sources are much more easily taken up and used than others, and some others are more leaky. So for example, nitrogen sources that contain amino acids, peptides, and especially urea, right? These types of nitrogen tend to be less work for the plant to take up. So if you apply a pound of urea, let's just take urea as an example. If you apply a pound of urea, the uptake efficiency, the nutrient use efficiency, the amount of that pound that's used is way higher than if you were to apply, a pound of nitrate, for example. So looking at how readily taken up your nutrient additions are, if you need to use nutrient additions for your system, is something important to take into account. and then get soil tests that are relevant to your biology. You know, we get the total nitrogen, total phosphorus, just to have an idea of what we have in there. But there's a whole suite of soil tests, and I don't know if we'll be talking about some of the soil tests that you can get in sort of the 4Rs discussion. And I'd also be happy to discuss with folks the kind of testing that we do here. But your soil tests, you should make sure you look for soil tests that are relevant, that are biologically relevant to your soil. So actually, like a total nitrogen or a total phosphorus doesn't actually tell you the status, the nutrient status of your soil as far as what's biologically active. And so there's a whole bunch of different ways and different tests that you can get done to look at that. So with that being said, I've just covered the tip of the iceberg here. This is sort of just a general introduction of how sort of we manage nutrients from an agroecological perspective. And so I'll just go ahead and stop there. And feel free, if you just Google John Mischler, Goshen College, you'll be able to find my email. Feel free to send me an email if you have questions about any more questions about how we manage nutrients on our farm, or how we do things, or any more about this agroecological perspective. So thanks, folks.
All right. Thank you, John. That was the clearest I have ever heard the interaction between plants and soils explained. And your discussion on the rhizophagy is really interesting. We knew that the soil supplied nutrients to the plants, but how they did that was always in question. So great discussion. Let's hold our questions for both our speakers till the end. We'll move on to Ben Wicker now from the Indiana Agriculture Nutrient Alliance, and let's hear about more of the agriculture in Indiana. Ben?
Yeah, thanks, Mike. I'm gonna try and share my screen here. Get my, okay, is that working? Okay,
We can see it.
Great. So I'm Ben Wicker. I'm the executive director of the Indiana Ag Nutrient Alliance, and I'll explain a little more about what that is in just a moment. But in addition to leading that organization, I'm a certified crop advisor with a background in developing nutrient management plans and working with farmers to develop fertilizer and manure strategies on their farms, as well as a farmer myself here in East Central Indiana on my family's diversified row crop, forage, and cattle operation down here in Rush County. So I'm going to talk a little bit about developing a 4R plan for your operation, and knowing that we have a wide diversity of folks, with the type and the size of their farms. I'm going to come at it from a pretty high level, but as we work through, I'm happy to think about how these frameworks might apply specifically to your operation. With full disclosure that my background as an agronomist is in traditional and as a farmer is more in traditional row crop and commercial ag production. So that's where I'm most comfortable, as opposed to some of the vegetable and other types of production. I'll probably defer maybe back to John on some of those specific questions, but happy to think through as best we can as we work through. And broadly, the principles apply regardless of the type or the size of farm that you have. So a little bit about IANA. It's a broad collaboration of all the major agricultural organizations, the Indiana Conservation Partnership, and some other conservation organizations that are really focused on education and outreach and keeping Indiana farmers at the forefront of proactive nutrient management and soil health practices that are going to make sense on their farm and improve their farm viability, but then also ultimately reduce nutrient loss to water. How we look to operate as a partnership is really around these four main areas of sharing goals, opportunities, information, and outcomes. Right along with that, and how that applies to this conversation is, as a partnership, we've established some practice adoption goals that are really couched in the 4 R's of nutrient management, which we're going to go into more detail in a little bit, as well as that framework of soil health. Understanding that, those two frameworks together is really what's going to allow us to most efficiently manage the nutrients on our farm. That is going to allow us to be as productive and efficient as possible, while also being good stewards of the environment. And so some of these goals that we've established, and what's going to be particularly pertinent to this conversation, are goals that we've established around routine soil sampling. And so, John referenced, making sure we get our soil tested. This is really focused on those testing for those nutrient levels in our farm and understanding what we have, and how that relates to how we utilize fertilizers and manures and other nutrient sources on our farm, and then using that information to establish a plan, as well as goals around, how do we mitigate the risk of nutrient loss around some of our application, and then ultimately protecting those nutrient investments by really implementing more of those soil health practices. John did a great job of kind of going through those nutrient cycles, but just again, a primer. As we think about the 4 R's of nutrient management, we want to think about it comprehensively. So not just nitrogen and phosphorus, but all the 17 essential nutrients that are required for plant growth, including potassium, sulfur, as well as all the micronutrients that go along with that. But when we talk about this practically, we really focus in on that nitrogen and phosphorus because one, those are the two of the most significant nutrients that are required and necessary for plant growth, and as well as those are the two that can have the most differing outcomes, I guess, or move off site and cause challenges downstream or off farm. So very simply, to think about it as we're developing a plan, I like to kind of break it down into these 4 components. And understanding that as John very well illustrated, there's a world of complexity underneath each one of these, and it's going to vary and be specific depending on your farm and your operation. But at very highest level, when you're thinking about developing a 4R nutrient strategy or nutrient plan, it's understanding your soil needs. So do you have all the information you need for that? So that's soil tests, that's soil test, or that's soil type, soil test information, understanding what it is that you're working with on your farm. It's understanding those crop needs. So as John was talking about, different crops have different nutrient needs. Grasses and cereals and things like that, need or will benefit from having nitrogen additions to them. Legumes like peas or soybeans or, your clovers and alfalfas in a forage situation, fix their own nitrogen. And so understanding those interactions of what those crop needs are in order to be successful is important. It's applying those nutrients using the 4R principles, which is what we're going to go into a little more detail on here in just a little bit. And then also importantly, documenting what we've done. And this is an area that we find across many Indiana farms that Indiana farmers do a great job, particularly with those top 3. They understand we've made great strides in understanding our soil needs. We're making great strides and understand how we balance that with our crop needs. We've made vast improvements over the last several years of making those applications utilizing 4R principles. But we have to also make sure we document, and that's important both from a on-farm perspective of if you didn't write it down, how can you make improvements, or you can't track and measure over time, as well as verifying to ourselves and others, right, that we're doing the best job that we can to be efficient. So that record keeping is an area that we find most folks need some additional assistance with. So diving directly into the 4 R's and understanding what that is. So the 4 R's of nutrient management is this framework that's scientifically based, that's really designed to maximize plant uptake of nutrients while minimizing risk of environmental loss. And when it comes to utilizing fertilizers and manures and all nutrient sources on our farms, it's understanding that we're using the right source of nutrients applied at the right rate, at the right time, and the right place. This is really going to vary depending on what cropping system that you're utilizing. As John said, we throw in soil biology into the mix, and that's going to be a whole other level of complexity that's going to require adjustment to your farm as you continue to work with this. But broadly as a framework, it's adaptable to all farms. And how I would encourage everybody to think about this is, when I know I need to add additional nutrients, regardless of what form that may be in, thinking about these 4 R's before making that application to understand how that's going to impact both the agronomic or the productive growth of that plant, and how that impacts my soil, but then also what that risk of loss is, and making sure I'm mitigating that as best as I can. So with that, I'm going to dive a little bit into the each specific R, and just give some very high level points about some considerations to make and some principles to follow when considering each one of these R's. So we're going to start first with the right source. So the important thing to understand here is, as John very well covered, different sources, are going to behave in different ways. And so the first thing we need to understand is, what nutrients am I applying? And so if this is using a, something that you're going to be purchasing, a synthetic fertilizer, or, the bag of fertilizer from your local ag retailer, or, Tractor Supplier, Rural King, or wherever that may be, that's understanding how to look at that label and know what the nutrient content of that fertilizer is. If it's something that is grown on farm, or that you're purchasing that's a more organic source, whether that's manure or compost, those are a bit more of a mystery, right? We can broadly look at book value and understand what they may be, but the most important thing to do there is to take a sample of that and test that. Send that off and get that nutrient source tested to understand, and at a minimum, knowing what the nutrient, what the nitrogen, phosphorus, and potassium levels are. But you can also get tests run through laboratories like IANA, Great Lakes, and some others to understand, what the micronutrient levels are of that nutrient source. This is really important information, because when it comes to determining how much of that nutrient we need to apply, where we need to apply that nutrient on that fertilizer source on our farms, it's really critical to have that information. The other piece of this, and John touched on this as well, is understanding what that nutrient form. So not all nutrients are going to be the same. Is that nitrogen, phosphorus, potassium largely available in an organic or an inorganic form? That's going to really affect when we start having conversations around the timing of that nutrient application and when we can expect that plant to take it up. And we may need to make adjustments to our plan depending on what that source and that form is. Broadly speaking, as was covered, your synthetic fertilizer, so that bag of 10-10-10 that you may purchase, from ag retail or your local supplier, is going to be largely, those are designed to be quickly taken up and are largely soluble. So the uptake on a fertilizer like that is going to be vastly different than a compost that may have more of those nutrients in an organic form. And as we said, they're going to have to go through a cycle before they're more readily available. All that caveated, right, with the learnings that we're having around, different forms of nutrient uptake and moving through, that's part of where some of this is, working and collecting that information and tracking and seeing how these different plans interact on your farm. From there, we have to set the right rate, and very simply, establishing the right rate of nutrients for that farm is understanding what that crop need is, minus what that soil is already going to be contributing, information that hopefully we've been able to ascertain based on testing and the other information we've gathered from that soil, and then using that difference then to calculate what our fertilizer, manure, or compost rate is going to be. So with the information of knowing this is the source of nutrients that I have to apply, with the information about this is the amount of nutrient that I need, then we can begin to tailor what that right rate can be, and have a very kind of basic example of that we'll go over at the end. But the rate is going to be important. as John said, because applying too little of the nutrients is going to not allow us to produce as effectively or efficiently as possible, we're not if we're underproducing or we're not maximizing production on those acres, we're having impacts on sustainability when we're working on that. But over application has those off-stream or off-farm impacts as well that are critically important. So when we think about place is important. Place is important to consider, at multiple scales. So place can start at the very highest level of I'm going to apply, to this field versus not another based on my soil test information, or even subfield, right? This soil test grid as opposed to another, or at a very small scale, this plot or this garden section as opposed to another, depending on those soil needs. But placement also gets down to that very micro scale around that plant. So am I going to apply the nutrient in the furrow or beside the plant? And these are all considerations that we have to make. Is it a nutrient that we're going to apply on the surface, or are we going to incorporate it into the soil surface? Broadly speaking, putting very soluble forms of nutrients on the soil surface, particularly if there's no living crop, and especially if that ground is, water saturated or frozen or crusted over in some way, are really risky applications in terms of loss. Because if we think about snow melt or rainfall coming down on that, and we have a very soluble form of that nutrient that's going to interact with that runoff and move off site. So place can mean a lot of different things, but considering when we're making those nutrient applications, what's my ultimate goal? Having that nutrient, that soil fed and that nutrient available for that plant to take up can really help us improve our nutrient use efficiency on how and where we place those nutrients. Time is also critically important to this. And this is one that's also going to be dependent on the soil, the crop, and the weather. So John gave the example of sandy soils versus, a high organic soil. That's going to differ how and when we apply or when we apply those nutrients. A very sandy soil that has very little nutrient retention or nutrient retaining ability, we're definitely going to not use the same type of timing strategies as opposed to maybe a soil that has a lot of organic matter that is able to take those nutrients, hold on to those and cycle those through that soil system. Crops are also going to be critically important to this as well. Really, again, focusing in on that strategy of we want to make sure those nutrients are in an available form when we have a plant that is there growing and able to take it up, because soluble nutrients without any sort of roots there in order to cycle those and capture those, what's not able to be processed into organic forms within the soil is really what's going to be suspect to loss. And so that's why we have to consider that plant uptake and that loss risk. So a couple different examples here of how we could think about this comprehensively when thinking about our nutrient management. And these are simplified for case of example, and be happy to talk about how we made some of these assumptions and back into some of these different calculations if there's any questions. But let's think about an acre of corn and using nitrogen as our nutrient for this. So we're going to use a source of 28% UAN, a very soluble and readily plant available form of nitrogen that's out there is what we have available to us to use. We know based on studies that Purdue University has completed, looking at the optimal rate of nitrogen, taking into account economics, plant uptake, and risk of environmental loss, saying that on average, an acre in Northeast Indiana is going to require 212 pounds of nitrogen per acre based on their field trials. From a timing perspective, we're going to look to split that application. So rather than applying that very soluble form of nitrogen all at one time, we're going to space that out and space it out within the growing season. So we'll make an application a very small amount of that nitrogen application at planting time, what they call a starter application, in order to really feed that plant as it's first getting started. But we don't have a large pool of that available nitrogen out there, suspect a loss if we get early heavy spring rains. And then we're going to make a second application, what they call a side dress application, in season. Once that plant is up, a foot to 2 feet high, and is really entering into that stage where that uptake curve on that corn plant is really going to take off, we'll make that second application with more of that nitrogen, so that it's timed when that plant is able to take it up. From a placement standpoint, we're going to inject it beneath the soil surface. One of the risks of UAN is it's in a soluble form, and so if it's applied to the surface of the soil and it's a hot, windy day, we can get a lot of what they call volatilization off the soil surface, where it will basically enter in a gas form, and we'll lose it to the atmosphere at that point in time. Has major or has environmental implications when we have that happen, as well as major economic and agronomic implications. At the end of the day, if we're not utilizing these nutrients, that's a lost investment on our part as farmers. And so to mitigate that, we're going to inject it beneath the soil surface so that it has the opportunity to interact with the soil as it works its way towards where the roots can take it up, and it's not suspect a loss across that. A second example we could think about is a more of a garden example. So let's take tomatoes as an example. We've tested our garden plot. We know that when we look at our phosphorus and potassium levels, they come back as low. We don't have a lot of readily available potassium and phosphorus within the soil, so that we know making an addition of those nutrients is going to have a benefit to that growing crop. For a source, we went down to our local retailer, and what we had available to us was a bag of 10-10-10. So 10% nitrogen, 10% P2O5 phosphorus, and 10% K2O nutrient. We look at some university recommendations, based on our soil test and nitrogen needs. And we see that, okay, about 0.5 pound per 100 square feet is the recommended amendment rate, in order to when we're going to be growing tomatoes. So at 0.5 pound, because we have a 10% a product that is 10% of those different nutrient sources, do the math with that. That's going to be a 5 pound per 100 square foot application. So depending on the size of our plot, we can make those conversions and figure that out. For timing wise, because again, these are going to be in very soluble forms as a synthetic fertilizer, we don't want to lay it out that fall before. I really like John's recommendation of compost, something that we know is going to have a slower breakdown and is going to fit within their system. That's an application you can make well in advance, or make more in advance of that crop. With a more synthetic form, we're going to want to time that more closely to when that plant's going to take it up. So we're going to make this application at that transplant time, and we're going to incorporate it into that planting bed, so that we don't have that soluble form sitting on that soil surface, that in case we get a heavy rain immediately following that application, that we're going to have a lot of runoff and loss risk from that. Again, both has water quality implications as well as lost productivity, because if that nutrient isn't where we placed it, it's not going to behave as we wanted it to go. All this, again, is layers and layers of complexity, right? Is going to be very specific to your farm, as well as your cropping system, as well as evolving over time as we test and we learn new things. The good news is it's not something that you have to figure out all on your own. There are resources that are out there available. You can look for technical assistance, whether that's through finding a certified crop advisor in your area, through your local soil and water conservation district. I know in Allen County, in the Western Lake Erie Basin in particular, there are resources that are available for folks that, if you haven't taken a soil test recently to see what your nutrient levels in your field are, and if you have manure that you need tested, there's resources that are available through those local offices. Purdue University, through our land grant, and John, I'm sure, has some resources developed out of their university as well, and there may be others, but Purdue Extension can be a great resource for finding some some of these different information sources. If you just want to read up and learn more on this, there's online resources you can find. I just cherry picked a few out of this for conversation. For more information on that 4 R's of nutrient management, and particularly focused on commercial row crop production, you can go to 4rfarming.org to learn more about the strategies and how farmers can apply those in their fields. For row crop production, just was recently released an update to the tri-state fertilizer recommendations. So they're tri-state because it's Indiana through Purdue University, Michigan State, and Ohio State come together to develop unified recommendations across the area that really look at nitrogen, phosphorus, and potassium in particular of best rates and nutrient management on those. And then for your vegetables gardens, Purdue has guides available for each, what specific crop you may be looking at, and development of those resources from there. So with that, I'd be happy to take any questions, talk about anything else in more specific detail, but I hope that was a useful high-level overview of the 4 R's considerations that you can make on your farm and some potential resources that can help get you started.
All right, John and Ben, I have to say you guys are a moderator's dream and a listener's dream with the way you worked off each other and the quality stuff you presented to us. So let's unmute and give these guys some questions. What questions do you have? I know we had a couple questions on how to source cover crop mixes. They are available. That's what I answered. We can help supply you, give you suppliers to find them, to either get the premixes or mix them yourself. The cover crops, there's a lot of information out here at the Midwest Cover Crops Council on the purposes of each plant and how you want to build your mix. What questions you guys have? What comments?
I have a question about the biochar. I was wondering, are there specific types of wood that are better to use to burn to make the biochar?
Yeah, that's a great question. And if you go online, you're going to find plenty of opinions. Generally, any type of hardwood is going to be fine.
Okay.
I would stay away from pines and other sort of high resin woods. But people generally use what they have availability of. So, there's some people who are using pieces of palm trees and coconut husks and all sorts of different things. So the good news is you can use lots of different things. I would just try to stay away from anything that's got a high resin content or anything like that. You have any more questions on that, or is that?
What about black walnut? I'm not sure if that has a high resin content, but I know it can be a problem with other plants in general.
Yeah, that's a good question. So I haven't specifically looked at black walnut, and it does have the jugalone, which can cause some issues with a lot of other plants. My guess is that using the black walnut wood for biochar would not be a problem, but that's a guess. So I haven't looked into it specifically. To be honest, I've not ran into anyone wanting to use black walnut because it's such a prized wood. So I haven't seen that used, but I haven't looked into it specifically. So if you look into it and still have questions, feel free to get back to me.
Okay, thank you.
Yeah, just from observations in the garden, I know tomatoes don't like to produce where walnut seeds are dropping, where the nuts are dropping off into. So might be something there.
Yeah, so the allelopathic effect of black walnuts is usually through their roots, is how they're affecting most of the plant communities around them. So yeah, definitely don't want to cite anything too close to a black walnut tree.
Hey, John, I've seen some people starting to incorporate wood chips into the soil, especially in the fall or late summer, and just putting them in raw and letting them work their magic over winter. What do you think of that?
Yeah, I mean, and I know Ben, knows a lot about this stuff too. This idea that your carbon and nitrogen, has to be balanced. So what tends to happen, this is the same if you've got a dead cover crop, let's say sorghum Sudan grass. It's got a lot of sort of tending towards the woodier side of the spectrum, lots of recalcitrant material. And when that hits the soil, if it gets incorporated, so if you were actually to put wood chips into the soil and incorporate them, then you're going to be pulling nitrogen out of your soil, because the microbes basically need carbon and nitrogen, right? They also need phosphorus and a whole bunch of other things, but they need carbon and nitrogen. So if you incorporate carbon into the soil through wood, then you're going to end up pulling nitrogen out of your soil to break that wood down. So if you're doing that, say during a season where you're not actually growing, like if your goal is to cultivate a fungal network, right, by introducing this high carbon material, which fungi are going to really like, then you might you might be okay, as long as you've got adequate nitrogen that coming season for the crop. Though it's in general, so we don't till, so we're not going to be incorporating anything down into the soil. And in general, it's good to stay away from actually incorporating wood chips into the soil, because they're going to pull all the nitrogen out in order to have them broken down. So we tend to add them on the top. That's how Mother Nature builds organic matter, is just stuff falling on top year after year after year after year. So in our systems, everything goes on the top, and you can build a nice fungal network through your wood chips there on top without pulling nitrogen out of your soils. So, and yeah, I'd welcome if Ben has stuff to say about that too.
No, I think you covered it really well. That just re-emphasizing, just paying attention to that carbon to nitrogen, and considering what crop you're going to be following. So if you're going to grow a corn or a grass or something that has a higher nitrogen demand, that's not going to be producing its own nitrogen, you may need to feed that soil a little more, right, in order to help balance and to make sure the microbes are always going to eat first, right? The soil eats first, and the plant is available. The plant takes what is available from that. And so if you have something like wood chips, or a really woody high carbon source, and to your point, grassy cover crops, things like that, cereal rye, and before corn is a common is a common one we hear about. You can really have short-term, in particular, nitrogen deficiencies as that soil is balancing out and breaking down that residue. You can overcome that by feeding some additional nitrogen to that, whether that's through a legume cover crop or through a nitrogen addition, to help balance that. So again, looking at it just comprehensively, right, of what's your goal and how's this whole system working together.
Yeah, speaking from the standpoint of farming and planting corn into 4 and 5 foot cereal rye with that high carbon nitrogen ratio throwing us off, I put 40, 45 pounds of nitrogen down with the planter to overcome the deficiency that is going to be coming up from that decay. But the good part about it is that nitrogen that's tied up is returned back to the soil in available form about tossling time, when the corn is looking for its most nitrogen. So working with these systems works.
Yep. Yeah, Mike, we do a similar, we plant quite a bit of cereal rye, in the fall in front of acres that are planned to go to corn. And that early starter nitrogen is key, but with that, we haven't encountered the yield drag or any of the nitrogen deficiency challenges that I know can happen otherwise.
Yeah. One point I was thinking of when both you guys were talking, we're in a new era of farming and nutrient management. It's always good to find someone that can act as a mentor, as a friend to you, as an advisor. So the people are out here. We can help you locate, or everybody will locate guys that can help you work through this, either gardening or commercial agriculture. So what other questions you guys got or comments? Give them another one. See if you can stump them.
I'm going to add a comment. The Allen County Soil and Water, here, I'll turn my screen on. We have free soil testing for small and urban farmers in the Western Lake Erie Basin. So that includes counties Allen, Adams, Noble, Wells, Steuben, and DeKalb. So if you have a farm that produces less than $250,000 of gross annual income, then you're eligible for the free soil testing if you live in the Western Lake Erie Basin. So give us a call, because as both John and Ben talked about, soil testing is super important. So that's just an announcement to give to you guys.
Yep. And new to Allen County, SWCD is a CCA, certified crop consultant, that can help us also. He's just come on board.
A little bit of extra emphasis there. The USGS just sent out a report of phosphorus loads into Lake Erie, and the Maumee watershed is just like, if you combine all the other watersheds, they would pretty much equal what's coming out of the Maumee watershed. So phosphorus leaving our systems and flowing into the Great Lakes is something we can address with proper nutrient management.
Yep. The phosphorus flowing in is driving the algal bloom. Excess nitrogen with it is increasing the harmful bacteria, the cyanobacteria produced by that algae. So both phosphorus and nitrogen is issues. Scott, you got anything to say? There's our soil sampler man right there.
Yeah, along with, I just want to add that with the new urban and small farms grant, also if you have gardens that you are going to use the produce off of that to sell, or to use in more than just for your own consumption, that also qualifies for some soil sampling. I will share a little bit. I've been doing this program for the last year for phosphorus, and I've sampled a little over 5,000 acres in this last year now, and that constitutes a lot of different people because most of these farms are all small. And what I've found is the phosphorus levels are usually either very low, because a lot of times on the small farms that have livestock, the manure is hauled closest to the barn, and that's just because even back in the times when we had dairy cattle 35, 40 years ago, it was the same way whether you have horses or tractors. You're in a hurry and you want to get it away from the barn, but a lot of times you want to get things done so you don't haul it as far away as you have as time permits. So the closer you are to the barn, the higher the phosphorus levels are, just because of that. And another thing is with the multiple animal units that are around, I have found that if your brother-in-law, your neighbor has a chicken barn and you have access to either cheap or very or free manure, you have a tendency of putting it on. And what we found is repeated applications like this has driven the phosphorus levels very high. So we've got to keep an eye on things like that too. Also, sometimes on these farms, I will take a sample out of the gardens. And the gardens usually have phosphorus levels that are sometimes 10 to 15 times what our levels want to be, just because, hey, you know what, if we put a little manure on our garden, that's great. If we put a lot on there, that's going to be greater. That's not necessarily true either. So just some things that I've found here over the last year. And yes, we still do have free soil sampling available. Some of that criteria is if you haven't soil sampled in the last 4 or 5 years, you're eligible. If you're working with a consultant right now, I say to please keep working with them, because you are doing exactly what our program is trying to get others to do, and that is to work with a consultant and basically make your fertility plan to a soil sample. So first thing, like everyone has said here, number one is to get started soil sampling. So that's my input. These guys have done a great job today. And so there you go.
So one of the questions I do run across quite a bit when in them gardens, how do they lower that phosphorus level?
Don't apply more.
Don't apply more, correct.
Is a good first step, right?
Yeah.
And I mean, that saves you money too, right? So
Yeah.
At the garden scale, you know, it's not like having too much phosphorus in the soil is going to start killing your plants. You just have excess phosphorus that could leave the system. So yeah, you stop applying phosphorus heavy sources, which saves you money. And I mean, the great thing about nitrogen is that you can get it from nitrogen fixation, you know, from plants. So there's actually very low cost ways to get your nitrogen that you need. So it's actually, you know, you're pretty good off financially if you want to reduce inputs at that scale, to be able to, you know, fix the nitrogen you need, not worry about phosphorus for a number of years because it's in excess.
Man, I thought I had you stumped there.
Yeah. No, I'll just piggyback on what Scott said of, you know, that I didn't dive into manures, you know, too much specifically, but certainly in my experience that bullseye effect around the barn of high phosphorus levels to lower further out is not a unique phenomenon. It's pretty common any place where there's been livestock production for a long period of time. But to me, that's also just builds that case of testing that manure source, knowing what the nutrient levels of that is, because then you can begin to assign a value to that manure. You know, for many years, manure was viewed as a waste, right? And that's why it was applied as quickly and efficiently as possible, because we didn't value it, you know, particularly with the nutrient levels and understanding how that can impact that word. With that said, you ask any old farmer, where's the most productive spot on your farm? And it's probably the old sow lot or someplace, you know, that has seen lots of manure over time. So it's understood inherently, but to value that manure by knowing what those nutrient levels are, you know, can help incentivize, you know, you as the farmer, right, to move it further off site and pay a little more to transport it. And if you don't need it on your farm, it may also generate some value to where, you know, you don't necessarily even have to give it to the neighbor. You know, they may be willing to pay a little bit for it, because as John mentioned, all these nutrients come at a cost, you know, in one form or another. And so you wouldn't have to necessarily make that purchase, or you wouldn't necessarily, you may be able to purchase it more efficiently than you could another source.
Very good. Questions, comments? Give us some more. We have 23 people on here today, so that's very good.
John, you mentioned that you add compost when you're flipping beds between crops. Do you do that with, like if you're pulling out, say, lettuce that's done for the season and you're going to add something else, do you put compost then in between the crops?
Yeah, so when we're flipping beds during the season like that, our standard protocol is to cut off, like for lettuce, for example, to cut them flush with the ground to keep the roots in the soil, because the roots actually will keep releasing exudates even after the top is removed. So we keep the roots in the soil, the roots will decompose, and add soil organic matter. And then we will add, it really depends on how that bed looks. We might add an inch or so of compost then on top of that to go ahead and flip it over for, whatever we might be putting in next. So yeah, we will usually add at least, so for example, if we're starting a bed from scratch, we might add, 2 to 3 inches of compost. But if we're just going through and flipping a bed that's already had that earlier compost addition, then we might just add an inch to sort of top it up. Does that make sense?
Yep.
Any questions on that?
I think so. Thank you.
So John, you mentioned building organic matter was one of our goals. That is one of my goals. I have this 5-foot cereal rye growing on top of the ground, and I have the roots underground. Where is the organic matter coming from to build organic matter?
And I wanted to get something straight. So if I understand your system, you said you've got cereal rye. You're planting into it green. Is that right?
Yes, correct. Yep.
And then you're using a roller crimper to terminate.
Yes, usually after planting, then depending the week or 2 or 3 after planting. Yep.
And then you're not doing any spray down.
No burn down on that, and some fields did not have any additional chemical put on them last year.
And so that's a really good illustration of, you just gotta choose your system and kind of what you're going for, because you can do no-till. And is it a no-till system? Are you?
Yes, yeah, no-till since the late 80s. Yep.
So my wife actually has done a bunch of research into no-till organic, and I think she's found things that you've probably already observed, in that if you've got weed pressure, no-till organic's pretty hard.
Yeah.
And if you increase the diversity of your cover crop mix, no-till organic can be pretty hard, because you need that cover crop to be at the right stage to terminate. Mm-hmm. So and how many acres did you say you're doing at a time, terminating at a time?
100 acres corn, 100 acres of beans yearly. So, yep.
Yeah, and then the other challenge people have is that if you're trying to terminate 1,000 acres, yep, you got to get it all terminated at the right developmental stage.
Yeah.
But anyway, that's your question was.
Yeah, the question was organic matter. How do we increase that? Is it by the roots, or is it by the top, or both, or one or the other?
Yeah, cereal rye, it's not known for having an extensive root system, but as far as building soil organic matter in the soil, I mean, those roots are gonna be staying in the soil and building soil organic matter. And then when you're laying down your cover crop and building, that mat, especially something like cereal rye, like if it was hairy vetch, since it's so full of nitrogen, it's going to basically just go away when it decomposes. But something like cereal rye that has more of the recalcitrant material, so when you're moving towards woody material, then you're going to have residual soil organic matter, which is basically microbes eating the plant material, which then produces the soil organic matter. And then, so a quick answer to your question is you're building it both from the roots, but also when you get soil contact with the recalcitrant cereal rye material. So if you're wanting to build soil organic matter, you've also got to encourage fungal growth, because there's a bunch of ways to lock carbon into the soil, and fungi tend to be one of the best organisms at creating that really stable humus that's going to really stay long term, because the carbon that's in your soil can also just get oxidized, metabolized by microbes and oxidized and go away too. So it's generally true that the more you can stimulate the fungal aspects of your soil, the more staying power your soil organic matter is going to have. And so things like no-till, right, are really good for maintaining those hyphae.
Okay, a neighbor down the road has 225, 250 bushel corn that goes out there in the fall and turns that into the ground. What's the effect of that?
So if I understand you correctly, you're saying he's taking the corn stubble and actually tilling it in.
Yeah, incorporating it in with a tillage tool, full width tillage.
Yeah, the predominant sort of idea on that is that if you can, like corn stubble, like corn can be pretty like tough, right? Like it's pretty thick stalks. And so the idea is that you needed to increase the soil contact with the stalks in order to get them to break down. But the thing is, that's also in this paradigm where the soils are not very alive, right? And so if you're lacking biology in your soils, it's going to be hard to break down that corn stubble. And I mean, it also really depends on what you're doing after corn. So can you build soil organic matter by tilling the corn stubble in?
Right.
I mean, you are increasing the rate at which the corn stubble is breaking down, right? If you're increasing soil contact, no question. But as soon as you open up the soil, you're providing a high oxygen environment for the microbes to start metabolizing all that carbon that's in your soil, and then you're losing it to the atmosphere again. So yeah, that's it. Having living soils that can deal with some of the more recalcitrant materials, I think is our best bet moving forward. And I don't, and you're the one, you've been doing this, so you've seen it. I think you're just kind of playing with me now. So
Discussion's always good. We had a question on any tips for building more acidic soil for growing things like blueberries. Anybody? Ben? John?
So this is something we've been doing. Indiana. Okay. Full disclosure, I'm from Illinois. I know. So in Illinois, we had one type of soil. I'm from central Illinois. One type of soil, these really deep prairie soils. Everywhere you looked, every direction, it was all the same all the time. I moved to Indiana, and it's like I can't walk 20 feet without getting into a different soil type. And so, so we've got these muck soils, and we've got these clay soils, we've got gravel, we've got sand. We do have prairie soils here. It's all, preaching to the choir. It's a fun puzzle to manage these diverse soil types. And so so it really depends what kind of ground you have on your farm. So you're right that these blueberries need acidic soils. So in Indiana, you've got two options. So you can find really sandy sort of patches, which we have on our farm, which those are really good candidates for blueberries because those will be highly leached acidic soils. Or if you have some of these what's called muck soils, which are basically old high organic wetlands, there's varieties of blueberries that can do really well in those high organic acidic soils. So your first choice is to see if you have a proper patch for blueberries on your property. Now, if not, the standard practice is to use an acidifying fertilizer, which there's a few different varieties you can choose from, and in this sort of the standard, whether you're going to use pine needle mulch or whatever it is you have at your disposal. Now, that being said, if you're going to try to change the pH of your soil, you've got to really, really, really want blueberries, because you're not going to just like do it and then walk away. It's something because if you're fundamentally trying to change the pH of your soil, it's something you're going to be working on forever because it's going to want to go back to the pH of your soil around. So if there is some other berry that you would like just as much, say like honeyberries or currants, and those berries don't mind the more alkaline pH soils, then plant those. But if you're committed to blueberries, just know that this is something you're doing every year that you have blueberries in the ground, unless you can find patches of ground that meet the criteria.
Great. Okay, Ben, any ending comments? You want to follow up on anything?
No, I appreciate the opportunity to share today. Encourage everybody to just think about this as a framework and as a system as they're developing plans, and don't be afraid to reach out for those resources and help, right? Because as we say, there's so many things that are, the blueberry question is a great one, right? We could spend an hour, right, developing a nutrient management strategy for how you're going to efficiently manage those blueberries for just one crop in one place. And so having a good understanding of what your goals are, what you're working with, and then lean out to that technical advice to help you along the way as you're learning and testing things on your farm is what's really going to be key. So thanks again.
Very good. We've come to the end of the scheduled time. I really want to thank Ben and John. This has been a great presentation, and I want to thank everybody that's joined us. That's what makes this work. So, thank you. This will be available on YouTube when we get it up there. So, everybody have a good day.
Thanks.
Folks.